Hi everyone, in this video, I'll be going over how to create this vertical tower. The steps are similar to the last video, but this one we do a vertical copy and we also array it all the way around to create more than one tower. To start, we're going to go here to units and let's see, we'll be working with feet. And here I have a brand new Grasshopper file. So now let's start by creating a point. And this is going to be where it's going to be located. And also bring in an X, Y, Z point. I'm going to type in point or construct point. You'll get a component that gives you an X, Y, and Z that is at 0. And this we can plug into this point component, and this way we can later on set a point and move the location of the tower. What we'll be doing today is something similar from last tutorial, but this time it'll be going vertical. And the geometry that we'll be starting with will be a circle. So let's double click here and go to a circle component. And you don't want this one, you actually want the one that is create a circle defined by a base plane. Now notice that it says plane and we have a point. We can plug in this point into the plane, but you can also do an X, Y plane, which is the same thing as this X and Y plane. Plug in the point into the origin, and this plane becomes the reference plane. It basically does the same thing because once you plug in the point into this plane component, it's just going to create a plane at that point. But it's good to understand that this XY component is the reference plane that we'll be using. Now we can change that reference plane to, let's see, we'll do YZ. And this way it'll change the location of the circle. So that's the power of using a plane rather than a point, because the point will always create it in the XY plane by default. But if we want to rotate it, that's where we can plug in a different component. Now let's move on to giving it a radius. So I'll double click here and go to 50. The next thing that we're going to do is we'll keep it simple and we'll just array this vertically using series. So we'll take the circle and we'll go to a move component and we'll plug in the circle into the geometry and we'll create copies by plugging in a series into the motion. So I'll go to a series component as well as a vector Z or unit Z. This way we can make copies in the Z direction. So what series is going to do is give us a series of numbers starting at 0 by default. Let's hover here. Then stepping by 1 and giving us 10 numbers. It's going to start at 0 and go all the way to 9. And as you can see, we have a set of copies here. Now, the spacing is really small, so we need to increase that under the step. So for the step, we'll go here into 20. And that will increase the step in between. When you're zoomed out and you double click here, it'll bring in the slider options. If you want to plug in a number, I like to double click and then go to 20. And now we have the spacing, and count is going to be how many copies. We'll bring in a slider of 15. And this allows us to create more. So now that we have these copied, now the idea is going to be to create a point that we can use as our point attractor. So automatically with this, if we brought in a loft component, we would have a pretty straightforward extrusion up, just going through all of these curves. But now let's go ahead and take this and let's change the scale of all of these circles using a reference point. So I'll go ahead and unplug this using Control. Now let's take this and create an endpoint going through all of those. Now notice that start and endpoint, they're both actually at the exact same location here. So what we need to do is separate those, or they're already separated here. So we'll have to just create a line or a polyline going through every single one of those, either start or endpoint. It doesn't really matter. Now that we have those, I'll disable the preview on those points, and we'll take this polyline and we're going to now create a point on that line. So point on curve, and point on curve will allow us to pick a point along that. So with this, we can now use our point attractor, because with this point, we're going to calculate how far this point is to each and every one of those center points of these circles. So I'll bring in an area component and plug in the circle into the geometry of these circles. Now I'll plug in a line, and quite honestly, this could be done with the midpoint or with the start point, but we won't be able to see what the idea is here. And let me just show you. So if we create a line starting this point, ending at those points, so going from one point to all those points, you'll see that this line is shorter than this other line, which means that the size of this circle is going to be smaller than the size of this circle, just by the way that this is laid out. So what we need to do now is take all those lines and get the length of each and every single one of those. Once we have the length, we have 16 values, and we also have 16 circles, which means that we can take all of those lengths and we can use it to scale every single one of these. But what happens is these numbers are really large. We need to remap them. So we'll go to Remap Numbers, and with Remap Numbers, we bring in two more components: bounds and construct domain. Why? Because construct domain is going to give us the biggest and smallest number to remap them to a number that will give us a good scale value. And this middle one, source, is going to be bounds, so the biggest and smallest number, and then value is going to be our original numbers. So our original values go into the value numbers, then all of these values go into the bounds to give us the biggest and smallest number, and lastly, we get the length to plug in the start and end number. Plug that into the target, and since we're doing a scale, it has to be smaller than 1 or larger than 1. So we'll go 0.50 less than 1.50. This gives us a slider from 0.5 to 1.5. This way we have a small number, making a copy down here, and a large number. Now we have map numbers, and the numbers are smaller and bigger than 1, which gives us a scale value that we can use now to scale all of these circles. Automatically, the center point is going to be down here, so notice that it scales it down. The center point is going to be every single one of these centroids. is it scales them all by a factor of 0.5. And now we'll take the map numbers and plug them into the factor. So we can disable the preview on the inside ones and see how our curve attractor works here. Move power. You can also change the scale value here. If you want them to become smaller or larger, this is where we can kind of play around with that. The other thing is our value of where it's being scaled is the center point. We used the start or end point. You'll see that it actually scales it relative to the side. And if the values you want it to be a little bit larger, I'll change these to 3 and change this smallest number being 0.1. Never really wanted to go exactly to 0 because that kind of usually gives you like a bad result here. But with this, now we can take all of these and bring in our loft component. Good here. And this is the way that tower and just create a surface on the outside. Okay. I'm trying to think what would be the best way to subdivide this. Use Isotrim. That's going to be kind of the most straightforward one. So we'll go to Isotrim. And I still haven't downloaded all the plugins for my Grasshopper, so I have to get on that. But let's go to construct domain squared. It's divide domain squared. That's what it is. And we'll plug all of these in. And hide all of the curves so you can see the geometry. Now this has a smooth form. What I like to do is turn it into straight sections. So I didn't do this on the last one, but we'll go ahead and do it this time. We'll go to deconstruct vrep. We'll get the vertices, bring in a polyline. Make sure that we'll set Boolean to true for our closed. And for our polyline, now we'll create a planar surface or a boundary surfaces here. And now we can join those together using vrep join and flatten the input. This way, we have a tower that has kind of faceted faces. And we can increase the U and V count. So go to like 15. Now with this, let's move some of this point around, see what that looks like. What I'm going to do now is, I think this would be a fun exercise, is to rotate this around this point. So if we have this point, that is where the location of where I want the rotation from. So we'll take this tower and we'll rotate it. Actually, before that, let's take these frames. I'm trying to think of what would be the best way to do it. Once we have it joined, we'll go to Edges. Multi-pipe. And we'll plug in both interior do a stretch size. We'll do a multiplier. Node size and offset. Now we can do that. We can take these panels and the multiply, and we're going to rotate those. So rotate, we'll start with pipes. We'll bring in series component. We'll plug in this point as our plane. Our angle is going to be determined by 360. So a circle in degrees divided by the number of copies. So 5. So 360 divided by 5 equals 72 degrees. And the number of copies, I'll make 5. We just have to remember that for the angle, we have to change that to degrees, and then we'll have a series of copies, 5 copies to be exact. And actually, the number of divisions is the number of counts. And this is what allows for a geometric pattern to be created. So let's do it for it to create 2, 3, 4, and so on. Now, the subdivide with this one, I almost feel like, so let's just further develop this now that we're here. Rather than rotating the pipe, I'm going to rotate the loft. This loft, I just need to make sure that it's capped, because now I want to make sure to join those together. I'll go to BREF, plug that into the geometry here. And now we're going to Boolean Union these together. Union. And we disable the preview here, and disable the preview for this stuff down here. You see that we have the tower. So I'll just disable preview on this. So we have this tower that is arrayed down the center, and all of our stuff is still alive here. Now, if some of these numbers are kind of small and you want to change them, this is the cool and the power of parametric design, is that we can always change these kind of on the fly. And now we can take this and subdivide each face and then rotate it around again. So it's kind of like a multi-faceted thing because we need to take one of these faces. So we'll need to take this, deconstruct VREP. We need one of these faces. So we'll go to item, list item, and we'll get one of those faces that just by luck happen to be our 0. This is what we'll subdivide. So we'll take all of this, bring it out here, and we will actually subdivide this and this. And now we have this VREP. Now it still creates the whole thing, so that causes some issues, but it's not like we can't fix that. Some of the things that gives us issues is the fact that we're turning it into straight sections. So this actually makes us go back to this portion where I actually want to intersect. So it gets a little bit complicated here. Intersect between VREP and curve. So we're going to take all these vertices, or all of these edges, sorry about that, flatten the input, and see where that intersects with this. So now we've extracted where they overlap. And we can take this and multi-pipe it. So this is where, like I said, sometimes we do need to work through some of these issues, but now that we have that fixed, yeah. 1.5000. So I like a lot of decimal numbers for this one. And up here we have another number, and we'll do a multiplier between this number and this number. For our strut size and for our node and end offset. Now I do have to make sure that this is a flattened input. This way it kind of works like that. And we can now decrease this a little bit. And this for the connection. Now we can take this and rotate it back using this component. So we'll copy this, just holding down Alt, and I'll bring in the multi-pipe into the geometry, and once we bring this back, we have all of those arrayed all the way around. And we still have the full capabilities of the parametric design here. So some of these will get a little bit harder to work with since we're developing all of these at the same time. But it is a cool exercise to work through a lot of the issues that sometimes we come up with. So yeah, this is how you create a tower that has like these copied arrays. You can just make one, or in here you can change this to number of copies. Number of copies. So if we just went to 1, you just have the single tower. And we have this preview and that preview. So we'll disable the preview on this. And lastly, for the panels, I'll just copy this down and bring in here's the thing. For the panels, it's going to be a little bit trickier, so we'll leave it here for now. There is a way to get those panels in, but for now, it's going to take a few more steps. So this was kind of how we can take that horizontal tower or horizontal building and turn it into a vertical tower using array and a few other things. So hopefully you found that useful. I did go through a lot of different things here. So let me know if you have any questions. If you have ideas or questions for future videos and stuff like that, let me know. Hopefully you found that interesting. Thank you for watching, and I hope to see you next time.